Hi everyone, in this video we'll learn about data warehouse concepts. So before knowing data warehouse concepts, first of all we should have to know what kind of data formats available in the universe. Mostly we have three types of data formats. So first one is a structured data and semi-structured data and unstructured data. Mostly everyone aware about structured data. Structured data means which is having rows and columns format. Let me open Excel. So if you see this example, these all are the columns and these all are the rows. So we can call this as a structured data. And let me go to the semi-structured data. Best example for semi-structured data, it's an XML or JSON format. Let me open XML or JSON format. Yeah, this is the JSON format. If you see this, yeah, open brace and closed brace and data, and it's in hierarchy format. So this is like a semi-structured data, and XML also looks like same. You can see here, this is the example of XML data. Okay, so JSON and XML comes under the semi-structured data. First one is a structured data, and second one is semi-structured data, and third one is the unstructured data. So unstructured data we can consider application logs and MP3 and MP4 text and image related files we can consider as a unstructured data. So mostly these all are the different data formats available. Next, we'll come to the data warehouse concepts. Mostly data warehouse concepts under OLAP and OLTP. Okay, what is OLAP means online analytical processing. So, okay, online analytical process. For example, it is having the historical data, the data which is useful for analysis purpose further. Okay, best example, I'm explaining with simple diagram here. For example, we are getting different data from different sources. It might be the Excel file, or it might be the cloud, or it might be the database. So whatever the data we are receiving, the data we are storing in one of the centralized database. The centralized database will called as a data warehouse. Okay, the entire data will do some kind of modifications, or we can consider as ETL transformations. I will explain about ETL transformation, what is the ETL and where we should use ETL. I'll explain later. So just for diagrammatic related purpose, I'm just explaining. Okay, this data we are storing in data warehouse. The same data will use for analysis related purpose. For example, whatever it is, it might be the sales analysis or marketing analysis. So this is called as OLAP, online analytical process. Will use for analysis purpose. The detail analysis purpose, it has historical data. Next one is the OLTP. So the name itself, online transactional processing. Transactional processing means it's just we are using for temporary related purpose. For example, whatever the data we are getting from application or any kind of database, temporarily we are using in one database. Later, the same data will delete, or the data we will load into the data warehouse. The OLAP and OLTP, the difference is mostly we have a lot of difference like normalization purpose and temporary storage and permanent storage related. We have a lot of difference. The main advantage is OLTP is a temporary related purpose, just a transactional purpose, and OLAP is analytical purpose. That means a historical purpose. Okay, this is the main advantage with OLTP and OLAP. Next one, the relation between OLTP and OLAP. Just now I have already explained. For example, whatever the data we are receiving from applications or users or database, whatever it is, okay, data temporarily we are storing in OLTP, and later we are doing some kind of the ETL transformations. I'll explain about ETL transformations later. So ETL means extraction and transformation and loading. So once we perform ETL operations, the raw data will be converted into utilizing format. That means raw data we will consider, and we will modify as business use case purpose. And finally, the same data we will store into the OLAP. The OLAP data will be useful for further analysis related purpose. So mostly we'll use for reporting purpose or any analysis related or any machine learning model development related purpose. We will use further this OLAP data. So this is the relationship between the OLTP and OLAP. Next, most important concepts are schemas. In data warehouse concepts, schemas are most important, and we have two types of schemas mostly. One is the star schema and second one is the snowflake schema. So star schema means one fact table surrounded by dimensional table. Surrounded in the sense one fact table is connected with multiple dimensional table. I'll explain in detail what is fact table and dimensional table. For example, if we consider e-commerce website, for example, Amazon or Flipkart or Mintra, whatever it is. So whatever the measured fields, measured table we can consider as a fact table. Measured table means, for example, we have revenue table, or we have commission table, or we have sales related table. So it's a measured field. That means measured. That means we can do aggregations or whatever kind of operations, numerical operations we can perform. Such kind of table we can consider as fact table. Rest of the remaining tables are dimensional tables. So dimensional tables means fact table data it will change based on daily. For example, today customer count is 10, tomorrow customer count is 11 or 12, whatever it is, and the revenue also will be increased on fact. But a dimensional table, data will be increased, but it's slowly. For example, the customer table, customer name and phone number, such kind of information, until unless customer updated the phone number, data will not be refreshed. So this is the advantage. This is the difference between the fact table and dimensional table. So this is about to star schema. One fact table connected with multiple dimensional table we can consider as a star schema. Same like what is snowflake schema means, here also same. While looking the diagram you can easily understand one fact table is connected with multiple dimensional tables. Again, each dimensional table is connected with sub-dimensional tables. So this is called snowflake schema. Why this star schema and snowflake schema means, why we are using this schema means, in SQL, further I will explain about SQL, structured query language. In structured query language we will use joins, different types of joins we will use. While joining one table with another table, we will use any one of the schema level. That means it might be the star schema or snowflake schema. Complex joins will be involved in any one of the schema format. That is the reason I am explaining about star schema and snowflake schema. So that's all about this video, guys. So stay tuned for more content. Thank you very much.